We'll go ahead and get started. If you are interested in getting the slides, I don't have any big reveal like the iPad Air with the pencil thing like just happened in the keynote. But if you're interested in the slides, that part that's in orange is really all you need to type in. So I'll leave that up there for like 5 more seconds. Okay. My name's Kyle Simpson. I'm known as Getify online on Twitter and GitHub and the other places that matter. If you're into that whole online stalking thing and you're interested in reaching out and giving me feedback, Getify.me, my plain black and white website, will give you links to all the places I can be found online. Today's talk is new rules for JavaScript in sort of the Bill Maher style, although I'm not nearly as funny as he is. A couple of quick background pieces before I get started. I am writing a series of books called You Don't Know JavaScript. They'll be published through O'Reilly. This link takes you to the Kickstarter. This was kickstarted earlier this year and was successful. But like most Kickstarter projects, I'm way behind. So I'm trying to get the first of these titles out very soon. Many people keep pinging me, asking me for updates on that. So it's coming as quickly as I can. Turns out that when you go around and teach JavaScript and write JavaScript and speak at conferences, it gets really hard to write books. So I'm trying to figure out the time and balance for that. But coming soon on those. Also, I'm an open web evangelist for a website called HTML5 Hub. Those of you that were in the morning keynote, you probably saw the announcement about the HTML5 Hub. This is a site sponsored by Intel, so we're enormously thankful for their support. And I have been helping, along with several other people, a lot of people involved in this effort. But the idea here is to really sort of highlight the common man's voice in this open web platform. There's an awful lot of sites that do a really good job of highlighting the really popular kids, but there's not a lot that's highlighting what real developers are doing, and that's really kind of my passion and goal for this site. So I'd implore all of you to join this site, help us contribute content, help us highlight the greatest things that are happening with the platform, and also start good and important discussions about where the platform needs to go. So the things that are lacking are also the things that we want to generate discussion around. We have a couple of high-profile sites that we have recently partnered to build, and I just wanted to point out the one that I helped build. We had an interactive article for Rolling Stone about a month ago, and then about 2 weeks ago, we had Museum of Mario that was launched. This is a site that is incredibly interactive about the history of where Mario's been. I don't know if the microphone will pick it up, but there's sounds throughout this game, and one of the unique things is this, of course, is all HTML5 experience. But this is also one of the few sites on the web that you can experience nearly the same thing on the desktop as you do on mobile. And we worked incredibly hard to try to keep that same experience throughout the history of the 30 years of Mario. And I like to think of this as interactive journalism. This is not just writing things, it's actually telling stories in a different way. On the note of Mario, I have HTML5 Hub shirts. And I have stickers, and I have gold coins. Those are chocolate, obviously, but gold coins. All of these are free giveaways. After the talk, you can come up and get them. If we don't have the size of shirt that you want, just swing by the Intel Hub, the Intel booth, and you should be able to swap for those. So I encourage you to go check out Museum of Mario. And as the final note on Museum of Mario, I am now open sourcing the entire code base for Mario. So that's up on github.com/ I don't know how quickly this will go, but that's up on github.com/HTML5Hub. Museum of Mario is what it's called. We'll let that run in the background. That may take a while. Okay, that's enough for the background. Let's actually get into this talk. Today's talk is really, well, before I say that, how many of you use code linters like JSint, JSLint in your code? So most of you are familiar with this. That means most of you are familiar with having your feelings hurt by the linter. You are, JSLint was famous for saying that it will hurt your feelings. So today's talk is going to hurt your feelings. But hopefully it's in a helpful way, because what I do is try to help teach JavaScript. I'm going to go through a number of things that I think are being done wrong with coding in JavaScript. They're being thought about incorrectly or being approached incorrectly. I'm going to point out some new rules, again, in the Bill Maher style. If I do hurt your feelings, please come afterwards. We'll grab a drink and we'll make sure everything's cool. So, to start out with, we're going to talk about a topic that can be a little bit controversial. How many of you believe or have heard the statement that JavaScript, because it's a dynamic language, that it has no types? Any of you? I should see more hands than that. Yeah, if you're being honest, you agree that JavaScript, well, I'm here to tell you that's incorrect, and I'll explain why. So first of all, new rule, stop thinking that it doesn't have types. And let me try to explain why. JavaScript as a language presents a developer aesthetic, a developer ergonomic that treats values as having different behaviors depending upon their type. Whether or not in the implementation side, or whether or not even from an academic perspective, you might say type is the wrong word for what's happening here. I don't want to debate those sorts of things. What I want to debate is whether or not what we see is different types. If I have the number 42 and the string 42, those two behave differently. There's true that you can take one and coerce it into a different value, and we'll talk about coercion in just a moment, but they actually behave differently. The Boolean behaves differently than the function. The object behaves differently than the array. Now, they share a lot of the same similarities, but again, underneath the covers, it really doesn't actually matter, and I don't think this should be an academic discussion. It should be a discussion about how we reason about our code. When we write code and we write something like the number 42, we're intending to use it as a number. And when we write the string 42, sometimes and oftentimes, we intend to treat it as a string. We treat things differently because they have different behaviors, so therefore I would argue JavaScript does in fact have types from the developer perspective. Moreover, if you were to go and read the ECMAScript spec, you would see that it in fact uses the word types to refer to these things. So that's my argument that I think we get mixed up in this whole thing. Well, it's not type enforced like some of the other languages, you know, Java or C++. It's true it's not type enforced, but it doesn't mean that there aren't types from a developer perspective. These are actually, according to the spec, the 7 well-defined types that are built into JavaScript. And as of ES6, we're going to be seeing a few more different types of numbers filtering in. Null, undefined, Boolean, string, number, object, and function. And by the way, that last one in the list, for years, I thought function was just a plain old standard type, just like everything else. Because when I use the type of operator, I get the word function out. Turns out, reading the spec just recently, I found out function is not quite a first-class type like the others. It's sort of a subtype of object that's callable. And in fact, in ES6, they're going more in that direction. There really won't be functions. It'll just be callable objects. But that's OK, because again, from our perspective, we know what a function is, and we know how that's different than an object, even though they can share some properties. When we use the type of operator, it will tell us what the type of something is. But there's a misconception that when you use type of A, that you're asking what's the type of that variable, and that's not what's happening. Values have types in JavaScript. The number 42, the intrinsic number 42, has an intrinsic type of number. But a variable is not enforcing those types. It's just a plain old empty bucket that you can stick whatever value with its intrinsic type in it that you prefer. So stop thinking that variables have types. It's really the values that have types. As an example, when I declare var a up here, I have not yet given it a value, but JavaScript has a behavior that it has a value in it. And that value is called undefined. Some people think of it as the absence of another value, but it is a value in the language. It is also a type in the language. There is a type undefined, and there is a value undefined. And those go one and one. The same thing would be true of null. So when we say type of A, we're going to get the string undefined out. But undefined is also an explicit value that I can assign around. I can not return from a function and result in undefined in various other ways too. When I look at A equal B, in other words, allowing some coercion there, when I look at those two, they are equal, and that's because both of them have that value undefined, even though we didn't explicitly give it to A. We did explicitly give it to B. Same thing is true of the type of operator. When we say type of A, it's going to give number because it's really saying what's the type of the value that's in A at the current moment. So values do have types, and those types can't change, but variables can hold any value at any time, and that's really what's meant by saying JavaScript as a dynamic language isn't type enforced. It's not saying that because it had a number at one time, it always has to have a number. We can put different values, but you cannot change the intrinsic type of a particular value. The number 42 cannot change. You can cast and create a new value that is of a different type from a developer's perspective, but you cannot change the value of the type of the value itself. Next, new rule, stop hating on the double equals and implicit coercion. This is a favorite one. Many of you probably have read Crockford's Good Parts, which we'll get to in just a moment. But before we do that, it really is one of those things that in the language, it's very hated on. Double equals just doesn't get a lot of respect in the language, and it's been called by many as sort of a design flaw in the language. And I'm here to push back and say I don't think that's true at all. I actually think it's one of my favorite parts about the language, that we have this tool, and I think the problem is that we don't learn how it works. So let's take a look at some of those things. First of all, how many of you believe or have heard the statement that double equals checks the value and triple equals checks the value and the type? I'm not leading you on at all, but to say that's actually false. Turns out you're going to get the same result, but that's not actually what's happening. The double equals allows coercion, and the triple equals disallows coercion. Now, that's how it's defined, and that's how it behaves. You can reason about things and come with the same outcome with the first set of statements, and that's how most people think about it. That's how it's mostly quoted in blogs and in books. But you can actually end up in the totally wrong direction if you reason about things incorrectly. For instance, the way you read those first statement, you would think that the triple equals was doing more work because it's got to check both the value and the type. And in reality, the triple equals is doing less work when they're different because it's not allowing any coercion, so none of the coercion mechanics are consulted. Here's a quote from the good parts, because that's one of the most famous places where it was told to us as developers, this is a flaw in the language, let's not do so. Doug says, when comparing any of the following values, always use triple equals or that not triple equals operator, which do not do type coercion. 0, empty string, undefined, null, false, and true. So that's good, safe wisdom, but most developers just stop right there. Turns out the very next sentence says, if you want the type coercion, then use the short form. Blessed by our own Doug Crockford, he said, if you understand and want type coercion, it's perfectly safe to use those operators. But most people have taken, and probably because the linter says don't use it ever, but most people have taken it, we just stop right there and we say, well, because I don't want type coercion, I won't use those operators at all. This is obviously a bunch of code, and it may be smaller for those of you in the back to read. It's not terribly important. I just want to point out this is a bunch of comparisons, obviously not exhaustive, but a bunch of comparisons between different values that might cause problems with coercion. And it turns out only 4 of the items in this list of 21 actually do create a weird, bizarre result. When, for instance, I'm comparing the empty string 0 to the value false, allowing coercion, we get a false negative, if you will, or a false positive in that case. We get a true out of it when really you probably wouldn't want to treat those two as the same value. But in all these other cases where I'm not marking it as oops, it gives you what you would normally consider to be sane results. Implicit coercion by far has sane results, and there's just a few places where it can trip you up. So that means if you're using values that are never in 0, and they're never in empty string, and they're never in the false value, and they're always in positive numbers, that are always in true or things like that, you're not going to get any weird behavior whatsoever out of implicit coercion. It's totally safe. I would give that as a textbook definition of throwing the baby out with the bathwater. There's a very important mechanism in our language, and we throw it out because we're worried about these couple of cases instead of learning what those cases are and avoiding those. Again, with numbers versus strings, 42 and string 42, pi and pi, those are equal, but none of these other ones are equal, and that's actually what we would expect. You don't want to treat the true value the same thing as the true string, or the false value the same thing as the false string. So in these cases, everything's totally what you would expect, and implicit coercion is, in my opinion, very safe and a powerful part of the language. So double equals and implicit coercion can be helpful if you learn and know what you're doing. Also, by the way, as a side note, never treat null and undefined differently. Some people like to think that undefined means it didn't have a value yet, and null means it had a value at one time and now I've taken the value away. As we saw before, undefined is a first-class citizen. You can sign that around if you want to. But I think it's actually safer and better with our code to treat these two as in the same bucket, as indistinguishable values. And here's why. Because the way that coercion works, null and undefined coerce to each other and only each other and no other values in the language. That means, from an aesthetic perspective, they could be treated as an indistinguishable value if you allow coercion to happen. Now, here's an example. I start at A with undefined, B is null, several other ways of getting undefined, and you see with those comparisons, allowing coercion, they're all equal and everything's perfectly sane. If we compare them to any other values, trues and falses and all those things, they never compare because those do not coerce to any other value in the language. You have a choice. You can write code like the bottom, which is to do things explicitly using the triple equals. This is what your linter probably is going to tell you to do. So if you wanted to test for A or B being undefined, you could say A triple equal null, or the type of A triple equal undefined. By the way, another side note, the type of operator is guaranteed to return you one of 6 fixed strings. It never returns anything but those 6 strings. Why are you worried about coercion when it's going to return you a non-empty string? Why use the triple equals there? Probably because you just don't want to think about it. And what I'm arguing for is that we should think about these rules and use the tools that are available to us. So you can do things explicitly, but I have kind of a general rule about my own coding that the more code that I write, the more chances there are for me to do something wrong. So when it's terse and still safe, I prefer to write less code, less chances for me to screw it up. Using our coercion rules about null and undefined, the same result will be completely safe with lines 4 through 9. You can choose between those two pieces of code, which one you prefer better, but I like coercion, and I like treating null and undefined as indistinguishable. What about the performance? This is a website called jsperf.com, and we did some tests about whether or not the implicit versus the explicit form of those two tests, whether they matter in terms of performance. So for some context here, the bigger the bar, the better. That is, the further it stretches to the right, the better. And the red bar represents the implicit test. So you see in all three cases, the red bar, the implicit test with implicit coercion, was a little bit faster than the explicit test. It's doing less work. Even factoring in those coercions, it's doing less work. So you might say, well, what about Safari? Of course, that's a big one. But overall, the picture that you should take from this is it's not terribly different in terms of performance, but it is slightly in favor of the implicit coercion. But the other context that's really important about JSPerf is how many operations per second we're talking about. This is roughly 400 million operations per second for those tests. That comes out to a few like nanoseconds and microseconds if you're doing your math. It's not going to matter. No matter what you do, it's not going to matter whether you're using implicit or explicit coercion. So this reframes the question, not what's more performant or what's better stylistically. The question that's reframed, and it's right there in Doug Crockford's book, is if you understand and want to use coercion, do so. And if you don't want to use coercion, don't. That's really all there is to it. Learn these rules of coercion. In fact, you don't even have to learn all the rules of coercion. Just learn the few places where they're pitfalls that you can fall into, and then use this behavior of the language as you go forward. So if you treat null and undefined the same, you're rewarded with simpler and possibly faster comparisons. Next, new rule, stop using anonymous functions. How many of you are jQuery developers or other frameworks that use the inline lambda style of functions, and you put your anonymous functions? Those of you not raising your hands are lying. You put anonymous functions all over your code. So here's an example. I made up something where I'm clicking a button. I'm using jQuery only because jQuery is small enough to fit on slides, not because I'm really trying to pick on them. But I've got an anonymous function here for my click handler. Then I set up a timeout for some stupid reason, and I've got another anonymous function. Then I do an AJAX request and set up another anonymous function. Now this code will work until you start debugging it. How many of you have seen debug stack traces with an anonymous function over and over and over again? Yeah. It's terrible, right? And then it gets even worse when you've minified your code, so you're getting anonymous functions and they're all at the same character in the same line of your file, right? So why not name these functions? All we have to do is rewrite this code to name things properly using what's called named function expressions. And the great part about named function expressions is that the name identifier does not leak into the enclosing scope. So the word handler is only available inside of itself and not in the outer scope around it. So it makes these names useful inside of the functions for unbinding of events or for recursion or things like that, but not polluting the enclosing namespace, and you can reuse the names as you see fit. Here I've chosen actual semantic names, shock upon shocks, and my code looks a little bit better because now I know what my handler and my request and response are, and my stack traces are going to be a lot better. By the way, those of you that use ifs, you should go ahead and name your iffy as well. It's not harmful, but it does tell you exactly in your stack trace which one of those anonymous functions you're talking about. We can go one step further, though, with this handler and request stuff. We don't have to use the inline style at all. We can just factor those things out in as standalone functions now because we've got an enclosing scope to hide them, and our code becomes even more readable and even more understandable. I just have a click for the handler calls request, and the request calls response. Now, some of you may push back and say, well, the reason I inline my code is because I'm using closures to try to keep track of variables. Turns out the language gives us a good solution to that as well. That's the bind function. Bind is usually thought about in terms of this binding, but it also gives us currying. And by currying our parameters into our functions, as I do right here, you can see that I'll pass along that URL. Whenever the request is bound, I'll make sure that the URL is passed along. So I didn't need a closure here at all. Well, it's a hidden inside of the bind behavior, but I didn't need an expressed closure here. And I have more maintainable code because my request and my response are stuck out. Now, you can embed them, of course, if you really need to, but it's not always required. So don't always feel like you have to nest 15 levels deep of anonymous functions. Named function expressions are always preferable. You can't come up with a single example that's going to convince me that it's better to use an anonymous function expression as opposed to a named function expression. Unless you're not creative enough to come up with names and then just use foo and bar and whatever, and that's fine. But name your function expressions. It'll make your debug stacks better. It'll make your code easier to reason about. Also, by the way, stop bloating all those function closures. This is a favorite of mine. So we write code like this all the time where we have some outer function with a bunch of variables. Let's assume that there was a bunch of extra data in here. Each one of these functions, by virtue of where they are declared, they have a closure. This one has a closure over the scope of init, which means that it's going to hold on to that scope for as long as those functions stick around. Even if you don't need that data anymore, it's holding on to those things in the scope. Just by virtue of the fact that they were nested inside of init, they have a closure over init scope. In this case, we don't really need to nest them. We could trim out and make smaller closures and more readable code. All we have to do is move those outside of init. Now they don't have a closure over anything that's happening inside of init, and that means when init finishes, all that data goes away and is garbage collected nicely. Now you could assume that the JavaScript engine's smart enough to do things, but I would prefer not to assume that the engine will optimize away all my mistakes. Prefer to just learn how this stuff works and write code that's better to maintain and better to perform. Next, new rule, stop abusing your function scope. This is actually one of my favorite rules that we'll talk about today. I just made up some crazy code here. This is code that's showing off some crazy for loops. What it does doesn't really matter, but what I want to highlight is a style of code that's very common, which is that we strew in our var statements throughout all our code. How many have you do var statements strewn throughout all the code? Okay. And so those of you that don't do that have probably learned the golden rule, which says move all your var statements to the top of your function. So we take all those vars and we move them to the top. Maybe we do separate var statements, or maybe we put them as comma-separated values on there. And we think that that fixes all our problems. Well, it does fix some of our problems. It does allow you to say, if I want to find where a variable was declared, I just have to find the nearest function keyword. That's certainly helpful in that perspective. But some of these variables are only used in small pieces of the code, which is why other people in other languages that have had block scoping for a long time have followed the principle of least exposure, which says define your variable only where it's going to be used and as close as possible to where it's going to be used. Which was, if you think about it, kind of the spirit of why you did a var e here. It's the same reason why you put a var I in your for loops, because that I is only going to be used for the for loop. So why not use a mechanism like block scoping in addition to our variable scoping that we're already used to? Why not use block scoping in addition to that to try to make our code more readable by having the variable declarations the closest place where they're needed? So you say, well, JavaScript doesn't have block scoping, so that's kind of a bummer. Well, the good news is that JavaScript is getting block scoping coming as of ES6. So we're going to get the let keyword, and the let keyword allows you to take a variable and bind it to a specific block. Here I'm showing a form of the let keyword that's been around in Firefox for over a decade, and that would be called the let statement. It creates an explicit block. Here I've created an explicit block, and I've bound E only to that block. And then down here I create another explicit block and put F, G, and I only on that block. This is my preferred form, by the way, of block scoping. I don't know about you, but I write code that's not correct the first time, and I have to refactor my code many, many times. I don't know, maybe I'm the only one. But what I've noticed about block scoping when I try to pepper that into my code is that it creates some extra mental tax, because when I used to just be able to wrap an if statement or a try-catch around a bunch of blocks, a bunch of code, and that not affect things, now when I start moving things around or wrapping blocks around it, block scoping can create problems. So I have to think closer about my blocks. I have to think closer about where variables are bound, which means that an explicit block for my variable declarations is, in my opinion, better than what would be called the implicit sort of hijacking of your block, because there's another form of this called the let keyword. It's a let declaration, just like var. And you could use let right here, just like we could use var anywhere, but let will hijack whichever block it's in and bind to that. So you could choose either of those two styles, but I think the explicit block is a little bit better, I think, just from the mental tax perspective of having to refactor my code. So I'll take some questions at the end. I know some people have some questions or want to push back. So these let blocks are explicit, and they do bind those variables only there, which means I only need to look nearest to the code that they're going to be used for those variable declarations. So the good news is that block scoping is coming, and I think it's better than manually hoisting your variables for the cases where those variables are actually used in one particular location. Not all of your variables will be like that. Some of your variables will continue to be used throughout an entire function, and for those I'd say continue to use var just like you always have. Now you have a useful signal, a flag that tells you let means localized, var means non-localized. So we look at this code and you say, well, that's great, except there's a couple of problems because it's not going to work until ES6. There's a perspective that feels like ES6 is forever away, and we're never going to get there because of what we saw in the days of IE6, and it took forever. Turns out that most of ES6 is completely done. Most of ES6 is already implemented in Firefox, already implemented in V8 and Chrome, therefore it's also in Node. And a lot of ES6 is already happening in IE11 previews. So there's great hope that ES6 is coming a lot quicker than you think. But we go even further that and say, most people aren't going to write ES6 natively and deploy that on the web. What they're going to do is write ES6 and then use a transpiler. There are transpilers that take most of what you can express in ES6 and turn it into ES5 code. So you maintain your code with ES6 and all the new nice semantics about reasoning about your code, but what's deployed is ES5, so it's totally safe for the web. So you say, well, okay, well, that's great, except there's another problem, and that is that the form that I've shown you here, the let block, which I think is better, isn't even coming in ES6. They chose to put the let declaration in ES6, but they rejected the let block, which really bummed me out for a while because I was going around teaching people that's the better form and it's going to be more maintainable for your code. For some reason, they chose not to put that into the language. But I've got news for you because things do get brighter, because this kind of code can work right now in ES3. You don't even have to wait for ES6. You can use let blocks right now, and let me show you how. Let's assume some piece of code like this, let A, and it's going to I put an A inside of that block, and when I reference that A outside of it, it gets a reference error. We know that it actually behaves like we want. It prevents A from leaking into the enclosing scope. Now, this is the kind of code that you'd write an author that would be maintainable, but this code won't work on the web, so we can use a transpiler to fix things. Turns out a little known fact about ES3 is that the try-catch block, the catch block already has block scoping built into it. So if I force an error by throwing an error and using the catch block's block scoping semantics, I get the exact same behavior. Now, you wouldn't write that code. That's terribly ugly code. But nobody writes the code that the CoffeeScript compiler outputs either. We all use these transpilers to write better code semantics and deploy things that work. Now, you may think this is a crazy thing, but I wrote a project around this called Letter. This is the link right there, and it does exactly this. It will take your code written with let-style blocks and transpile it into code like this. You may think this is just some crazy Getify invention. Turns out the official transpiler from the ES6 committee that's being maintained by Google, it's called Tracer, and when you use let semantics, the way they transpile is using try-catch. And now you may say, well, try-catch is ugly and it's awfully slow, isn't it? Isn't it slower? It's true it's a little bit slower than, say, an IFI. It's true there is some performance overhead, but the authors and maintainers of this particular tool have a bug open with V8 to tell them to fix the performance of try-catch, because they're relying upon this as the story for how we all get to ES6 coding. So maybe it's not quite so crazy. And by the way, letter allows you, it has a simple little flag in it. It will write code like we saw here. It will write code like this by default, but you can flip a simple little flag, and instead of writing this kind of ugly code, once we get to the ES6 days, or once you want to target ES6 browsers, it'll write code that looks like this. So it'll take your let blocks and turn it into let declarations for you, all right out of the box. So maybe block scoping is something we should start using. But by the way, let is not the new var. If you've heard that from somebody, there are some famous people that have been going around saying, just do a global find and replace of all your var keywords and make them lets. I don't agree. I think they're both useful. I think it's an additional behavior on the language. If you reason about it, learn how the things work. So I wouldn't recommend getting rid of your vars just yet. Also, by the way, loops love block scope. Here's a little snippet from that previous code. Again, this is just junk code, but if you're paying close attention, you'll notice I'm declaring an inline function inside of a loop, and that's the canonical way that we get bitten by the lack of closure around that. So the typical way we solve this problem, that instead of having G, instead of having this function close over the same G for each function and getting behavior we don't want, we just do this IFI thing where we wrap the IFI around it. We've created a new scope for it to close over, and that's the typical solution to these sorts of problems. Well, it turns out that the let block binding is going to make it a lot easier for us to solve, because instead of doing that kind of ugly IFI code, you can simply do let blocks or let declarations inside of these things. A let block here, creating an H, it will create an H for each new loop, and therefore these functions will close over different values of H and it'll behave as you expect. But it gets even better than creating let blocks because there's a special behavior defined in the spec when you use the let keyword inside of a for header. So look up here in the for header. If I move the let into the for header, it now will rebind that variable for each iteration of the loop. And it'll helpfully give it the value that it had at the end of the previous loop iteration. So we get exactly what we want with far less code, and we can reason about our code a lot better. We can get exactly what we meant by doing for var I. Now we can use for let I and get exactly what we expected. So I say let loops for the win. Using block binding with loops is a big win. Okay, next, new rule. All of you need to hand in your membership card that allows you the opportunity to use the this keyword in your programming until you can come up to me afterwards and recite the 4 rules that I'm about to teach you for how the this keyword gets bound. Because this is one of the most crazy confusions across the entire language. People don't understand exactly how it works, and they do start doing crazy stuff like var self equals this and other bizarre things to try to work their way around something until the code works, and then they back away from it and they say, oh, that's a house of cards, I don't want to touch it. And you're laughing because it's true, you've done this in your own code. Well, let me show you the 4 rules as how the this keyword gets bound. And let me explain to you that the this keyword gets bound by one and only one identification, and that is how the function is called. You have to go to the place where the function is called. That's called the call site, is sort of the fancy term for it. Go to the call site and inspect how it's found. And there'll be 4 rules that you need to ask about the call site of a function call, and those are the only 4 rules you need to do to understand the this keyword. By the way, here's some examples of crazy people not knowing what the hell they're doing with this. This.self equals this. What in the hell was that person thinking? And then even worse, this.method.call this. It's just an example of not understanding the language, and so you do crazy stuff instead. All right, so this is a bunch of code. I'm not even going to explain all this code. You can go back and look at it. And by the way, this little icon that I have in several of these slides, if you click that link, it should pop up a browser with this code already in it, so you don't even have to type it. But this code illustrates the 4 rules that I'm about to tell you, and not only does it illustrate them, it gives them to you in precedence order. It tells you what order to ask those questions in, and this proves how those rules work. But let me just shortcut you to what the 4 rules are. So here's how the this keyword gets bound. The first question is, was the call site used with the new keyword? You may have heard that the new keyword has something to do with class instantiation or whatsoever, and that's totally not true. And I'll get to that in just a moment with the next rule. But calling a function with a new keyword creates a new object out of thin air, and it assigns it to the this keyword for that particular function call. That, by the way, means you can hijack almost any function in the language and call it with the new keyword, and it will create a new this for you, and it'll helpfully return that this for you. So it's not that there's special constructors in language, it's just functions that are called with new. That's the first rule, was it called with new? If so, it's going to use that new object. If that's not true, it goes on to rule number 2, which is the call site binding overridden with an explicit call or apply? The call and apply methods in JavaScript use the first parameter as the this object. So if it's an explicit binding, that's the this that will be used. And by the way, you need to be careful about looking for hard-bound functions because it can mask where the true call site is. But if you find the true call site for a function call and figure out whether or not it's using a call or apply, that'll answer number 2. If it doesn't use that, it goes on to number 3. Is the call site an unowned object? That's like when you do something like a.foo and call a.foo. There's an owning or containing object context at the call site. And if none of the other 2 rules have applied, the 3rd rule is, was there an owning or containing object? If so, use that object for the this keyword. Finally, and when we're not in strict mode, if none of those rules have applied, default to the global object. If you're in strict mode, by the way, it just defaults to undefined. But those are the 4 rules, and those are the order. So what I want you to do is write these down on a Post-it note, stick it right next to the Post-it note where you have your password on your monitor, and now you'll never be confused about the this keyword again. It totally makes sense. Just find the call site. It's only magical or confusing when you don't find the call site and instead you try to do other crazy reasonings about the this. By the way, when you do var self equals this, that's really often just misguided because var self equals this is a huge neon sign to you that says what you really are doing is you don't understand the this mechanism, so you're just going back to something that's more helpful to you, and that's lexical scope. That's exactly what's happening. You're cutting off the this bindings at the knees and falling back into lexical scope. So my suggestion to you is, if you find yourself doing this a lot, not that it's never the right thing, but it's often misguided. If you find yourself doing this style programming, but you're doing an awful lot of these var self equals this, you're probably doing it wrong. You're probably doing too much work. Either embrace fully how the this mechanism works, or use lexical scoping and don't use this at all. But trying to mix the two is usually misguided. Let me illustrate. Here I've got my beautiful, awesome controls object, and I obviously need to reference some properties on the controls object. But I get into this case where when I bind a click handler, like here I'm binding a click handler, jQuery internally is going to do a .call on that function and bind it to the DOM object, which is not what I want. So the usual solution that people do to this is to do this crap with var self equals this, and they reference the self inside of the function. Again, you're cutting off the knees of the this property mechanism in JavaScript and just using lexical scope, which is crazy to me because it's more work. It's harder to do it that way. Why not just learn the mechanism? So it turns out there's a mechanism built in directly into JavaScript, and it's called bind. We can bind the function to the this keyword, and then this works just fine. No problems. And we're not doing any of that weird crossover where you have to think about both models at the same time. It's either this binding or it's closure binding. But don't try to mix the two in the same lookup. By the way, we can make this even better by factoring out those functions, as I said before. So I can factor out the handle function and reason about it a little easier. The bind works exactly the same way. We reference the function, we bind it to the this. Now on line 6, it'll always reference the correct object. This is maybe a slightly controversial one because I'm not a big fan of one of the things that's coming to ES6, and that's arrow functions. And I'll explain why I don't like arrow functions, because I think basically the arrow function is just a fancier syntactic sugar for var self equals this. The new functions that we're getting look like this. They have these little arrow symbols with, without the function keyword, and you just do the block. And inside of an arrow function, the this keyword is bound lexically, which is why I say it's exactly like var self equals this. Instead of it getting its own binding, the arrow functions don't behave by any of those 4 rules that I just taught you. They only use lexical lookups, which might look like a good shorthand, but you've gone back to short-circuiting the this mechanism and using lexical instead. Again, I just argue it's better to use the mechanism that you prefer instead of trying to mix the two. So don't try to be so clever and mix and match your this style code with your closure style code. Learn both, use both. I have projects that use both, but I don't try to mix them in the same lines of code. Final rule. Stop using new something constructors to instantiate and inherit classes. And notice all the air quotes that I'm using there. This is probably maybe one of the more controversial things, but I'm going to argue for you that there is no such thing as class orientation in JavaScript, even though they're adding a class keyword to the language. That's just more confusion. There's no such thing as class orientation in the language. It's a different mechanism, but let me explain the comparison that I'm going to make here. So OO is the traditional label that we use for, and we call it object orienting. Now, I actually think that OO is an appropriate label for JavaScript and Lua, and maybe those are the only 2 languages, because there's very few languages that actually allow you to create first-class objects without classes. JavaScript might be the only language that deserves the title object-oriented. All the other languages that you know about that are Java and C++ and all that, they all use classes to create objects. So they probably should have been called class-oriented, but I can't change people's minds about what OO means. So I created a new term that I call OLU. And the comparison here is OO style coding versus OLU style coding. OLU stands for objects linked to other objects. I'm going to argue this is how JavaScript works at its core. We can embrace the way it actually works instead of trying to pretend that it works some way else. This is really a comparison between class-oriented mechanisms and delegation-oriented mechanisms. There are those that will argue that those are just 2 sides of the same coin. But I think that's kind of like saying an apple is just a red-orange. They are fundamentally different mechanisms, and we can recognize those differences and embrace them instead of trying to conflate the two and hand wash over them. So let's look at what class-oriented code means. The typical metaphor for class orientation in those languages is you have a blueprint for a house, and then when you build the house, the builder copies the behavior from the blueprint into the actual physical house. The house doesn't ever refer back to the blueprint at that point. It's got a copy of that. And in some ways, at the compiler level, that's how true class-oriented languages work. You have a parent class, and when you instantiate it, you are doing a copy, a left-to-right sort of behavior into these instances. And in fact, when you inherit child classes, except for things like virtual, you're copying the behavior from the parent class into the child class and then into his instances. So notice these are left to right and top to bottom mechanisms. That's how class orienting works. Now, when we try to do class orienting in JavaScript, we use this sort of code. We have new keywords and we do dot prototypes. And by the way, these are only constructors by convention because we used a capital letter. It's kind of bizarre, but we start referencing this arbitrarily named object foo prototype. It's not a special object, it's just an arbitrary label for that object, but we think it's special because it's foo.prototype. And then we do this crazy stuff to link the prototypes together. And when we instantiate our objects and we call on line 22 b1.speak, quote unquote, everything works. But your mindset has told you that what happened was a copy behavior. And in reality, that's not what happened at all. And so because you have this problem of concept here, you go and use some userland library that there's hundreds of out there to fake class orientation inside of JavaScript by doing all of this stuff behind the scenes and faking the copying and stuff. In reality, that's not what happened here. There was a linkage. So like a magician that does a magic trick, I'm going to tell you what to look on. Look directly at these things so that when I perform this magic trick, you don't get confused, okay? So what you need to look at, here's the mental model that we started out with, that was implied by that code. We had some objects, but we also have these functions and these implicit relationships between the two. And this is just, you know, diagram porn for you, but you can go back and take a look at these. This is what's implied. This is the mental model you need to use to understand fake class orienting in JavaScript. And in fact, this isn't even it. This is the full diagram, which took me well over a day to create. And you notice that some of the same stuff here is correct, but there's new stuff here. There is a nice part about this, and that is that JavaScript is amazingly internally consistent. All of the places that you reference stuff in the language behave by the same rules that they behave on with your objects. And that's kind of a cool part of the language because you can traverse these arrows understanding the rules and things are consistent. But it's also probably not the case that you're going to print this out and stick it next to those other two post-it notes on your monitor to do this sort of code. So this is just a harder way of doing it. What if we could do something, the exact same mechanism, but in a much simpler way? I love this shirt. Your mom is so classless. I totally want to buy this shirt and wear it for this talk. So delegation oriented. Let's talk about what that means in my last couple of minutes with you. What does delegation orienting mean? Well, we have these arbitrarily labeled objects, foo prototype, and when we create a new A1 or B1 or something like that, we're not doing a copy. What we're actually doing is a delegation link. It's called the prototype mechanism. We create an object called A1, and he is delegation linked to foo prototype. It's an object linked to another object. And delegation means that when you try to call something on object A, and he doesn't know how to handle that property or method, he simply delegates up the prototype chain to another object. It's just objects linked to other objects. So all these objects are linked, and bar prototype, in fact, is just another object that's linked. And these are objects, so you see these are just objects linked to other objects. That's what's really happening at the core of JavaScript. And you may think, oh, it's just a semantics, but this is a fundamentally different mechanism. The arrows go from right to left and bottom to top in the way JavaScript works natively. So let's go back to the bad old code. This was the foo prototype way, and I'm going to show you what things to look at. Look at this object, look at this object, and watch that object. Keep your eyes on those three objects, because that's what we care about. We care about objects linked to other objects to delegate to each other. Now I'm going to perform my magic trick, and I'm going to simplify this code and get the exact same behavior out. I still have an object linked to an object linked to another object. Notice I don't have any constructor functions anymore. I don't have any references to dot prototype. I don't have any of that confusion. And I kept these as capital letters because people feel good about capital letters with things, but these are just objects. They're not functions anymore. There's a foo object, a bar object, and a b1 object. And the delegation works exactly the same with far less code and far less mental model. Here's the money shot. This is the diagram you now need to learn. There's no more functions anymore. It's just objects linked to other objects. Embracing the way the language actually works instead of trying to make it look and behave like some other language. I think it leads to easier to write code. By the way, one last point on this. Reflection about objects, asking about their relationship to other objects. When you do class-oriented code in JavaScript, or what's fake class-oriented, you have to reference things like dot prototypes, and you have to keep references around to their constructors. You can't just ask two objects if they're related to each other very easily. But in OLU-style code, bar is related to B1, bar is related to B2, foo is related to B1 and to bar. You just simply ask about the relationships between two objects. And you don't confuse things with this and new and classes and all of that other junk. So quit trying to mimic these more complicated classes and the inheritance and just embrace the way JavaScript works, which is OLU delegation. When the new class keyword comes out in ES6, your temptation is to get really excited about that and say, I can finally write classes. It's not a new mechanism. It's still going to behave exactly the way I just explained. It's just a different syntax sugar on top of the same mechanism with all the same complexities and confusions. So that's it. I've got 2 or 3 minutes left. Are there any quick questions?